note taker for today. Do we have a volunteer in the room who might help out by taking notes? Robin, thank you very much. Spared me the trouble of asking you. All right. Yeah, all right. So you get brownie points for that. That's very good. All right. Welcome to Token Binding. It's 9 a.m. in the morning here in Bangkok. At least that's what my clock says. So it must be true. So let's see here. How do you move? All right. Since it's the first session of the morning, let's just take an extra couple of seconds to look at the note well and remember what it says. You're subject to IPR, the IETF IPR regime while you're participating in this working group. All right. This is our agenda. Thank you, Tony. Unless anybody has something to add or remove from the agenda, I suggest we get started. So we do have one person who is actually needs to be in two places at once here. So I was going to actually offer Nick to go first if you want to do that. Or do you want to, I mean, it's sort of, you can do that? All right. And if the working group is okay with letting Nick talk about zero RTT and TLS 1.3, I guess, before Brian and other items, because he actually has to be in HTTP biz as well. Or sorry, in also HTTP biz. Yeah. All right. Do you want to start there with zero RTT? Oh, let's do that then. Sure. We got them all queued up here. Right.
That one's in the full screeny button.
Well, yeah, this is the only slide for this one.
There we go.
So for the TLS 1.3 draft, I've updated it to reference the final RFCs. Oh. Or I can adjust it. Yeah, so I've updated this draft to reference the final RFCs. Otherwise, there's basically no text changes to it. I think it's ready for a working group last call.
Right. Unless anybody has something to add, we're just going to start the working group last call, that 2-week process, well, later today, I guess. Not hearing anybody object to that, so we'll drop a note to the list. All right.
So for zero RTT with token binding, as you may know, there was previously a working group draft on this that has since expired. The chairs have asked me to just go over the issues with doing token binding and zero RTT together and some of the options for how that might be done. So next slide. I'm going to talk about why we might care about this combination. What are some of the things that makes it interesting? I'll talk about some of the ways that some of the assumptions that we might make of an attacker trying to attack this combination versus just plain token binding. Also, I'll talk about the options for what to allow with combinations of zero RTT and token binding, and this also has a lot to do of which TLS exporter to use when. And then I'll talk about the difference in the security properties between those two exporters, and finally cover some implementation considerations to consider when choosing one of these paths. So next slide. So basically the problem with doing zero RTT and token binding is there might be some clients that want to do both of these on the same connection, and doing token binding in early data requires using the early exporter master secret instead of the exporter master secret for deriving the signed value, and that gets into some interesting issues. So next slide. When evaluating this, making some assumptions about how this is set up, I'm assuming that token binding keys are in hardware, that they're not extractable. I'm assuming that when I say that an attacker has access to the key, this is they have access to an oracle to sign arbitrary operations. They don't actually have the bytes for the private key. I'm assuming that an attacker is not going to substitute a hardware-backed key store with a software-backed key store that the attacker controls. There are some interesting attacks in this space by forcing the client to re-authenticate and rebind to a new key, but that is orthogonal to the discussion around zero RTT. Those attacks can still be done with normal token binding. So I'm going to sort of exclude those for this talk. And I'm also going to assume that if an attacker has access to the client session cache, they also have access to the token binding oracle. So this is basically sort of, all of this is assuming that our attacker is sort of a client malware type attacker. The reason for sort of focusing on such a powerful attacker here is that if the attacker doesn't have access to the client session cache, they don't have access to any sort of keys related to the early exporter secret. And that basically becomes looking at zero RTT in TLS 1.3 without token binding. Yes, Ben?
Yeah, Ben Kadek, you need the session cache to do RTT, to do zero RTT at all. So
yeah. Yeah. I was just saying that the attacker in this case has access to that. So next slide. So the first thing to consider for zero RTT and token binding options is, do we even allow it at all? Right now, draft IETF Tokbind TLS 1.3 says that they are not allowed together, which is heading to working group last call. The way that the expired zero RTT draft gets around this is it adds a new TLS extension that sort of overrides that and allows that. But one possible option that I think is reasonable is just decide you don't do zero RTT and token binding together. If we decide we do allow zero RTT and token binding on the same connection, the next question to ask is, can a token binding message be sent in early data? You could say, no, you don't allow a token binding message in early data. You do allow some application data to be sent zero RTT, but you can only send a token binding message once the handshake has complete. Let's see. Whether this is useful depends on the application. Since we've only been looking at an HTTP mapping in this working group so far, this probably isn't that useful. But other applications, say where the server is speaking first, this might be useful. I don't know. If we do allow the token binding message in early data, then we start looking at exporters, because this is when the early exporter master secret needs to be used, at least for the token binding in early data. So next slide. I think there are three options for which exporter to use when assuming that we are allowing the use of the early exporter master secret. The first option is to always use the early exporter if zero RTT and token binding have been negotiated. This is what I described in the previous draft. Another option is to have the client switch to using exporter master secret as soon as possible. This is sort of very vague. If there isn't some sort of application level signal or other signal for the server to say to the client, you must use the exporter master secret, then this is just the same case as above, because an attacker can just send the, keep sending early exporter master secret and use that for the lifetime of the connection. And then another option is you use early exporter master secret when you're in early data. You use exporter master secret for everything post handshake. This is unimplementable because there's no way to guarantee that the early data, as the client is writing it, ends up in early data instead of ends up post handshake. So it's not really an option on the table, but there for completeness. So next slide. When looking at sort of the security differences between these two exporters, what it basically comes down to is what point in time was the token binding key used to sign. When the exporter master secret is used, this is what is done in token binding as specified in RFC 847123. The token binding key is used right when the TLS handshake is finished, once the finished messages are sent. On the other hand, when signing over the early exporter master secret, this is just proving that the whoever sent the token binding message had access to the token binding key at some point after the new session ticket for establishing that connection was used. So you send the, in the first flight, with like one RTT handshake, the server sends the new session ticket, then at some future time, the client does the resumption. You only know that that signature was valid over, or you only know the signature was signed at some point after that new session ticket was received, but you don't know anything about sort of the point in time of that connection. Let's see. When the zero RTT case, if this signature is sent in early data, there's also the chance that the attacker didn't have access to the key at all, but it just took the client hello and the early data and replayed it verbatim. So I'll talk about that a little bit later, but I'm sort of considering the client malware attacker for these two scenarios. For the first scenario, an attacker can get access to the key at the beginning of the handshake, and then even if it loses access to the key, as long as that connection is still alive, it can continue to use token binding messages on it. And this connection doesn't need to be from the machine where the keys are, because the attacker can proxy the oracle to wherever the attacker is controlling it. In the second case, basically what is happening is, again, the attacker can be proxying the key oracle to an attacker-controlled machine, but in this case, the attacker can continue to use the signature. It can make a bunch of connections to the server, get a bunch of new session tickets, pre-compute the early exporter master secret, do all of the signings, and then at a future time when it doesn't have access to the token binding key, it is creating those connections and sending token binding messages with that signature. So this basically limits the attack window to the lifetime of the new session ticket, which RFC 8446 says it must not be greater than 7 days, unless this ends up being like RFC 6919, which is must, but we know you won't. So getting to the topic of replay, I'm sort of glossing over this here in that if you were to do the same setup but without token binding and send some data in zero RTT, you still have the same replay concerns that you have in TLS 1.3. And token binding isn't really adding any extra protection to prevent that replay. So it is an issue. Token binding doesn't really make it any better or worse. There's also an edge case where an attacker has access to client secrets for resumption and can replay the client hello and token binding message with new application data. But if the client is able to do that, or if the attacker is able to do that, then it can basically just perform this attack where it pre-computes signature values. So that's sort of about it for the security differences. Then the last slide is talking about some implementation considerations. If you take an approach where you switch exporters partway through, there needs to be some sort of signal in the token binding struct which exporter was used so that you know which to use for doing the verification. It might be possible to define something where you don't need a new TLS extension, but for simplicity, it's just easiest to define a new TLS implementation, or a TLS extension, sorry. So those are all of the slides that I have covering this.
Right. Yes, feel free to line up. Just to get some context, I think what we should be trying to do is to figure out what the working group wants to do here. Do we want to take on solving, specking some of this stuff? Do we want to drop it on the floor? What?
Can you go back to the previous slide? Ben Kaduk.
Oh, previous, sorry.
Yeah. So you have these two cases about the access to the token binding key after new session ticket or the full replay. And the second case, the full replay, is sort of uninteresting in some sense, because the protections against that are sort of the same sort of protections you would need in general for zero RTT.
Yes.
But the first case is kind of more worrisome because it's sort of turning a single compromised access to these token binding keys into a reusable for, air quotes indefinitely, up to the 7 days of the session ticket validity.
Yep.
And that sort of seems antithetical to the entire goal of token binding. So it's sort of, and the TLS. So it's sort of philosophically hard to get excited about wanting to do that.
Yeah, so the way I sort of think about this is we're already looking at an attacker that is sort of client malware resident on the machine, so we don't know what sort of bad things it's doing. In the first case, though, once that malware has been identified and removed, then basically the threat is over. In the second case, it's once it's been removed, then 7 days later, the threat is over. So part of the consideration, if someone wanted to do this, might be, well, how long has this threat been going on, and how long can we live with, how long can we take to mitigate it? Do we want it basically immediate once the malware is removed, or can you live with this longer duration?
Mike Jones, Microsoft. Trying to wrap my head around the situation for zero RTT with token binding. I'm going to ask a question about zero RTT without token binding.
Sure.
Given you can capture and replay an early data packet and have it succeed, what are the mitigations that use of zero RTT have to take in the first place? I've heard told that, for instance, you must make sure that the data in the initial packet represents an idempotent operation, such that if it's replayed, it has no effect, which is an interesting layering violation to implement. It may be possible in some application contexts. Your thoughts?
Yeah, so I don't remember all of the text in the TLS 1.3 RFC about it, but having idempotent or similar requests is one of the things. There are, I think, some other potential mitigations that servers could use, but they're not like completely foolproof. So one example is the server could make tickets be single use and keep track. This ticket has already been used for a zero RTT assumption and won't let another one happen. In practice, for something with a large server fleet, that's basically going to be impossible to coordinate. Looks like Ben has some more to say on that.
Yeah, Ben Kaduk. So I did pull up the text from RFC 804046 about zero RTT replay attacks. And so we say the applications have to be specifically engineered to be safe under replay, which minimally means idempotent, but in many cases, it may require stronger conditions, even potentially constant time responses for some sorts of things. And so, Mike, I guess there is at least one application that has been specified after TLS 1.3 is out that does make use of zero RTT data and allows all of their protocol messages to go in zero RTT data, which is Acme. And the way they do that is by having every Acme request accompanied by a single use nonce, and the server has to keep state on that. And so it really is idempotent in the sense of it's only going to be applied once because of this nonce. And so that is safe against replay in this regard.
At the cost of the normal TLS guarantee, where your data is delivered exactly once in order in a stream, is violated.
Right. So I guess my question is, what should we do? Do you have an opinion here as a previous author?
So my opinion right now is to do nothing, which means that we don't allow token binding and zero RTT on the same connection. I think that if there is working group interest in this at a later point in time, that the previous draft might be a good starting place, and then can work from there. Yeah, that's my suggestion.
Right. Anybody have another opinion? Anybody who wants to stand up another draft right now? Yeah. I see shaking of heads. Oh. And Dick, you're sitting on a draft right now? No. No. All right. I think it's a good suggestion. Obviously, it's a suggestion that the working group would do if we're not presented with any other option, right, or any other alternative. If somebody wants to present a draft that does zero RTT, it's always a possibility, at least for as long as the working group exists. So I think at this point we'll have to leave it at there. At this point. We don't, from like a procedural standpoint, we never had zero RTT specifically mentioned in our charter, as far as I can remember. So we're not we're not failing to dot any T's and crossing any R's from not specifically not covering this. So yes, we can certainly just do nothing.
Okay.
All right. So I guess we'll leave it there. Do you want to say anything about this?
No, I guess the other question is, does anybody actually currently have a use case for token binding with zero RTT, or planning on turning zero RTT on for everything, which would then stop them from doing token binding?
Was that a question directed to the room or to me?
Well, you're in the room. If you have an answer, feel free.
I think Google is going to be turning on zero RTT on many properties. But I'm not turning on token binding, so I don't see it as I don't see the lack of this as a blocker for that. I think those are sort of separate decisions.
Okay.
Oh, go ahead.
Mike Jones. I assume you'll take this tentative decision to the list. And
Well, yes, but note the fact that it's not actually a decision, right? No, so much as a sort of failure to have any other options on the table, right? Because we have an expired draft that we can't force people to have an interest in, right?
I understand. I think for
But
clarity,
yes, right.
in the potential ecosystem,
All right.
it would be good if the chairs would make
All right,
an affirmative statement
saying we will no
that
longer.
the working group showed
Yes.
no interest
Yeah.
in pursuing this
Yes.
work.
All right, I think that's a fair point. It helps, as you say, with a little bit of clarity. All right, and that gets us to Brian for maybe the final installment of city backgrounds.
Yeah, so this should be pretty short. HTTPS token binding with TLS reverse proxies, maybe the final installment. Welcome to Bangkok, you haven't already been here. So a little bit of quick context. I like to. Sure, for all four slides.
Discovered. Yeah, we can go.
All right.
Can use it inappropriately too.
I might. So a little bit of quick context. I try to just give some background on drafts so we don't jump right into things. People that maybe aren't familiar with it can follow along at home. This draft is designed to support cases of token binding where there's some kind of TLS terminating reverse proxy system in place in front of the actual application. And this is really common deployment architecture. You see it with, on-premise systems where you have an Apache or an Nginx terminating, or an F5. You see it in cloud deployments where you have Amazon's application layer load balancer, Cloudflare, those sorts of things, CDN type front ends, where the application is sitting behind in some respect the actual system that's terminating TLS and doing the TLS. And I wanted to provide a mechanism, a standardized mechanism, which via passing the token binding message in, or the parsed validated token binding message from that TLS termination layer back to the HTTP application layer via some specially designed headers. And what this ultimately does is allow, from the client's perspective, that those two components to function as a single logical unit, performing HTTPS token binding in a way that the client doesn't know the difference, and they can do together, sort of work together to perform the operation of binding tokens and verifying bound tokens in a way that's consistent with what HTTPS token binding provides, and do so in a way that the header names are standardized and the value of such headers are standardized. So hopefully you could have turnkey kind of integrations between disparate systems. Any front-end TLS terminating reverse proxy that implements this could be turned on to do it, pass the same headers back in a known named format, and back-end applications would then, you could turn it on and they would know without any additional configuration or anything what headers to look for and how to parse them and what the semantic meaning of it is. And again, the whole idea here is to facilitate this reverse proxy and the back-end server functioning together as though they are a single logical server-side deployment of HTTPS token binding. That's the idea. Basically, it really comes down to a few headers and how you encode the token binding message in them, and what the rules are about validating that and stripping headers and sanitizing and passing that information to the back end. I was going to ask you to advance the slide, but I can do it myself. So some notable happenings since the last time we were all together in Montreal. I published draft 6 of this and really just switched around some sections headings based on some feedback from Martin. He wanted to find something and couldn't find it because it was buried. So I brought this particular section up to its own top level section. In the intermeeting time, we had a major browser decide to drop support for token binding, which isn't directly relevant to all this, but it's kind of a bummer in terms of, at least to me, pushing this work and hoping to see it widely adopted. That certainly undermines, I think, some of the incentives of getting this stuff out there and working and deployed, but we press on. So shortly after that, we had a belated working group last call. Thanks for owning up to that, Leigh. It being belated, and thank you for doing it. And only one comment was received during the last call period, and basically that was from a gentleman that we've heard from a few times before, and it's always the same issue regarding that there's not enough text in the draft describing how this doesn't prevent against client collusion attacks. As a result, there is some text in one of the core token binding documents, and the reaction from the working group was basically pushing back and saying there's already enough coverage of it. It's not really something we're trying to address or talk about here. You've gotten more or less more airtime on it than probably you need to, and nothing needs to be done in this draft. So basically, the consensus from the working group was that the one comment received, there was no action to be taken on it. The only action then that was taken, similar to what Nick said, is I published a draft 7 and just updated the references to the now RFC versions of the 3 core token binding specs, as well as a reference to TLS 1.3, the RFC version of that. And so that's all there really is on it. So it's supposed to be a joke, but trying to find a document shepherd now. I think we're at the point where it's ready to move up.
I can do it.
I don't know if you or Leif want to do it, but I don't see any reason not to proceed at this point and move it on up into the IESG. And with that, looking ahead to 104 in Prague, hopefully this will be submitted to the IESG for publication. I'm not going to be in Prague anyway, for whatever that's worth, and hopefully there's nothing to discuss at that.
Yeah.
That should have been easy. I think it was.
I think that's it. We're gonna shepherd this document, and well, I heard John volunteer. So and yeah, so I think we'll definitely be done by Prague. All right. You know, getting into, thank you. I think that's it. If there are no questions, I think that's sort of it for more or less for with sort of finishing up TLS 1.3 and deciding not to take on zero RTT. I think that's sort of it for the working group as well.
So long and thanks for all the fish.
Well, yes. So I think this is sort of heads up that unless something dramatic happen, I don't think we need to meet in Prague. And Dick is feeling lonely.
Question for Brian. Dick Hart speaking. Are there any implementations of the reverse proxy?
There's one fully compliant implementation for Apache that I'm aware of. I've heard rumors that maybe there's an Nginx plugin that kind of sort of does it. I'm not sure how much it's been updated to reflect this. And at previous meetings, there's been statements to the effect of, well, like Facebook is doing this internally and some things like that, but I don't have any verification of that. So right now, the implementations are open source modules or plugins for popular web server type things.
All right. And that puts us at open mic. And while you think about open issues and other things to talk about, let's just repeat this, that I think probably we won't need to meet in Prague, and I think at that point we should be considering closing down the working group. Does our AD have anything you want to add, or just I don't see anything coming down the pipeline. There might be related work in the future, but that doesn't necessarily mean that the working group needs to be kept around. So I think with that, and if there's no other issues, I'd like to thank the working group for your hard work. We actually finished, right? Yeah. All right. Thank you, and you get most of the meeting time back. Very good. I brought it, but man, you can't have everything.
It's a sad world when we become your fashion icons.
Should be short. Thank you very much.
Thank you. Okay.
There should be at least a blue sheet. Thank you. So should we have a chat with Tony? Yes, we should have a chat. Tony says yes.
He's making nodding motions.
Yeah. Did Ben sneak out already? Yeah, he snuck out. I guess we'll go find him.